All right, let's talk about how modern software gets built. I want you to imagine building a giant, intricate castle. You've got two choices, right? You could try to carve the whole thing out of one single massive block of stone, or you could build it with thousands of individual Lego bricks. Today, we're going to find out why building with those little Lego bricks might just be the most powerful way to create software.
So, quick question for you. What do companies like Netflix, Amazon, and Uber have in common? I mean, besides being household names. There's actually a secret weapon in their code that lets them operate on a massive global scale and innovate like crazy.
And that secret is microservices. It's a way of designing software that has totally flipped the script on how huge applications are built and managed. And that's exactly what we're going to break down right now.
But, to really get why microservices are such a big deal, we have to understand the problem they were created to solve. And that means we need to take a look at the old way of doing things, something called the monolith. This is the perfect way to think about it. A monolithic app is like a Jenga tower. It's one big, impressive structure where everything is tightly interconnected. But you know the game. You pull out one wrong piece and the whole thing comes crashing down. Microservices, on the other hand, are Lego blocks. Each piece is small, independent, and self-contained. You can add new blocks, swap them out, or change a section without any risk of toppling the entire castle.
And that's the huge, terrifying risk of a monolith. A single bug in a tiny part of the code, say in the payment system, could literally crash the entire website. Suddenly, nobody can log in, nobody can browse products. Everything just stops. The stakes are just incredibly high.
So let's peek under the hood. In a traditional monolith, everything, the user interface, all the business rules, the database, it's all bundled together in one giant codebase. This is what we call tightly coupled. It means that if you want to change one tiny thing, you have to retest and redeploy the entire system. It makes updates slow, scary, and really, really risky.
Okay, so if the monolith is the big, clunky problem, what's the elegant solution? Well, this is where our hero, microservices, finally enters the picture.
So here's the official definition. Basically, a microservice architecture takes one big application and breaks it down into a bunch of smaller, independent services. Each one is built to do just one specific job and do it really well. It's kind of like having a team of highly trained specialists instead of one person trying to be an expert at everything.
And here's what that actually looks like. Instead of one giant block of code, you have a separate service for handling users, another for orders, another for payments. They all talk to each other through something called an API gateway. Think of it like a central receptionist that directs all the incoming calls to the right department. And here's the magic part. You can update or expand the order service without ever having to touch the others. It's a game changer.
Now, this whole approach is built on a few key ideas. Single responsibility just means the payment service only worries about payments. It keeps things simple. Loose coupling means these services don't share their internal code. They just talk through well-defined channels, like colleagues sending emails. And decentralized data is huge. Each service is in charge of its own data, which is what truly keeps them independent and prevents one from slowing down another.
Okay, that's all great in theory, but how does this actually work when you, say, buy something online? Let's walk through a real-world example of an e-commerce order.
So you find something you like, you hit Buy Now. That request goes to the API gateway, which sends it to the order service. Now the order service creates the order, but here's the cool part. Instead of bossing other services around, it just shouts out into the void, "Hey everyone, an order was just created." The payment service hears that and says, "Oh, that's my cue to process the payment." And the inventory service hears it and goes, "Got it, I'll update the stock count." It's like a perfectly choreographed, decentralized dance.
Now, how these services talk to each other is a really big deal. One way is synchronous. It's like a phone call. The order service calls the payment service and literally waits on the line for an answer. It's simple, but if the payment service is busy or down, everything grinds to a halt. The other way is asynchronous. It's more like sending a text message. The order service sends its order-created message and just moves on, trusting that other services will pick it up when they can. It's way more resilient, but a little more complicated to set up.
So at this point, microservices probably sound like magic, right? The perfect solution? Well, not so fast. Like any powerful technology, it comes with its own set of challenges and trade-offs. So let's do a little reality check.
The good stuff is amazing, no doubt. Independent scaling means if you have a huge sale, you only need to beef up the order service, not the entire system. That saves a ton of money. Faster deployments mean you can release new features multiple times a day. If one service fails, say the recommendation engine, people can still buy things. The rest of the site stays up. And you can even use different programming languages for different services, letting your teams use the absolute best tool for the job.
But here's the other side of the coin. Instead of managing one Jenga tower, you're now the mayor of a whole city of Lego castles. There are just so many more moving parts to watch. Communication between services over a network is always going to be slower than communication inside one single application, and trying to keep data consistent across dozens of separate databases, that's a huge challenge. When something breaks, tracing a single user's request across 10 different services to find the source of the problem, well, that can be a real nightmare.
All right, so we've seen the incredible power, and we've seen the pretty serious complexities. This brings us to the most important question of all. Are microservices actually right for your project?
This table right here is basically your cheat sheet. If you're building a massive, complex application with lots of different teams working on it and you know you're going to need to scale, microservices are probably a fantastic choice. But if you're building a simple app or you have a small team and limited resources from managing complex systems, sticking with a good old monolith is often the smarter, simpler, and faster way to go.
But look, when the scale demands it, the benefits are just undeniable. Let's circle all the way back to the beginning. The reason that Netflix, Amazon, Uber, Spotify, and Airbnb can do what they do, the reason they can serve hundreds of millions of people and constantly push out new features, is because they have mastered this way of building software.
So at the end of the day, it really comes down to this. Microservices are all about building applications that are scalable, resilient, and perfectly suited for the cloud by breaking them down into small, independent, manageable pieces.
And that leaves us with one final thought for you. As you dream up your next big idea, which path will you choose? Will you build a single, perfectly crafted monolith, or a flexible, sprawling universe of microservices? There's no single right answer. It all depends on what you're trying to build.